So average rate of change. Okay. It is a rate of change, right? So it's a rate that describes how one quantity changes in relation to another one. Right? If you think about slope, which is really what average rate of change is, it's just the slope between whatever two particular points they picked. It's the change in y over the change in x. You see delta y and delta x, okay? Or the more formal formula you have is subtract the y's and subtract the x's, and you're good to go. It is that simple. All right, so you don't always have to have a perfectly straight line. Okay, you can have the world's weirdest equation, right? You could have a parabola, I guess, it's going down and then back up. Okay, and the average rate of change between the 2 points that they care about, this point right here and this point right here, is still going to be the exact same thing. The average rate of change is the change in y over the change in x between those 2 points, no matter what, if there isn't even any points connecting them, or a line connecting them, I should say. So we're going to jump into example 1. We're going to find the average rate of change over the interval from -2 to 1. So at -2, here we are on both the red and the blue graph. At 1, here we are up here on both the red or the blue graph. Doesn't really matter. It's the same average rate of change for both those graphs between those 2 points. So to find the average rate of change, all right, we have to find the y values that are paired up with it. So we make a table, or we just write the ordered pairs out. So we have -2, -3, which is right here, left 2, down 3. This point of intersection is at 1, +3 for either graph. And now we're going to use those values to find the change in y over the change in x. So, kind of gap it like that. That's how I typically do it. I say, how far apart are they? Okay, and how far apart are they? So from -2 to 1, we're going up 3. From -3 to +3, right here, we're going up 6. So my change in y over my change in x would be 6 over 3, which would give me 2. Okay? Or 2 over 1, however you want to write it. The other way, using the formula, you would take the change in y, so I would do subtraction. You have to be careful, whatever way you decide to subtract with the y's, you must subtract with the x's. So if you do 3 minus -3, you have to do 1 minus -2. So I'm going to do the second point minus the first, so 3 minus -3. And then again, the second point, 1 minus -2. That's going to give me 6 over 3, which again is 2, same answer. So the thing you want to be careful about, if you chose my first, or you like my first method, right here, 6 over 3, using these guys up here, is if you go from -2 to 1, you have to realize you went up. That's positive. If you go from -3 to 3, you have to realize, hey, I went up 3. That's positive. And then you solve for the answer. If one of these was reversed, going from 3 to -3 would switch it, and that'd be -6. So you have to be very careful to make sure that you are actually going in a positive direction. So from -2 to +1 is a positive direction. I'm going up 3. From -3 to +3, yes, I'm going in a positive direction up, or to the right, I guess, on that side. That's going to be 6. And then you're good to go. Example 2. Given the function f of x equals x squared minus 3x plus 5, determine the average rate of change. So now we're given a quadratic. They're not giving us the picture. If you wanted to graph it, you totally could. They want it over the interval from -3 to 4. So we need to find the value. So we go to our calculator, type this into the calculator right here, go to your table, and then get specific values for -3 and 4. And again, we only care about those values, so you could just write those down. If you wanted to write them down as ordered pairs, you could. Okay, I typically like to do that gapping method, so from -3 up to 4 is a difference of 7. And from 23 to 9, when we do that difference, okay, notice I'm going down from 23 down to 9, so that's going to be a negative number, -14. So now I just put the change in y. This is my change in y, and this is my change in x. So it's -14 over 7, which gives me -2. If you don't like that method, doing it that way, that's fine. You can totally use the subtraction method, so the more formal way. So I'm going to take and do the change in y. So 23 minus 9, because I'm looking ahead and I'm thinking that makes it a nice number, right? That's 14. Okay, and then I have to do the x's. Okay, so I have to do the same order. Okay, so since I did 23 minus 9, I got to do negative 3 minus 4. So negative 3 minus 4, that gives me negative 7. And again, you're probably going to want to use your calculator to double check this, just because, you know, people make mistakes. We're human, right? But both ways I get negative 2 is my average rate of change, and we're good to go. That's it.